So if you remember from last time, we looked at cases where we had P of A union B, or you could say this is A or B, all right? And the equation we used to find this probability is P of A plus P of B minus P A intersection B. And in the case when they're mutually exclusive, if they are mutually exclusive, this becomes equal to 0. In the case if they are mutually exclusive. If they're not mutually exclusive, then they're going to be, and then there's going to be an intersection between both. Today, we're going to be looking at cases where it's dependent and independent. In other words, when there's a intersection like this. So there's going to be A and B, which basically means P intersection, A intersection B. All right. This, the equation for it, we looked at it very shortly last time. It's equal to PA times PB last time. This is how we looked at it last time. We just multiply it when we looked at the tree diagram. But the actual equation for this is PBA. What does this mean? So this is a definition of a conditional probability, meaning, so this is conditional probability. Conditional probability is basically when an event B occurs after event A is occurring, because event B will be affected by event A. A simple example of this would be if you have a bag, okay, or a box. Inside it, you have like 10 marbles, okay? So, or like, let's say we have 1, 2, 3, 4. You have 4 marbles, all right, of random colors. Let's say we have 2 green, 2 blue, and 1 red, all right? If you take a random marble outside, and we take 1 marble outside, 1 marble, the box will be left with, let's say, for example, we took a green marble outside, the box will only be left with 1 green marble inside, 2 blue marbles, and 1 red marble. So here, if you notice, our sample space has changed. So initially here we have a sample space of, we have 1, 2, 3, 4, 5. We have 5 marbles in total. Here now our n has changed to 4 marbles total. So this is when your n will change. This is what conditional probability means, meaning now if you want to select a marble, the probability will change. Let's do the analysis of this. So we have 2 green. If we look at our sample space, green is equal to 2, blue is equal to 2, and red is equal to 1. All right? In this case, we have green is equal to 1, blue is equal to 2, and the red is equal to 1. All right? This is the case here. If you notice, when the green marble is taken away, this case they call this without replacement, meaning that the marble that has been taken out is not being put back in the bag. So the marble is going to be removed and it's not going to be replaced again. All right. This is what is meant by conditional probability, as in your sample size is going to change. Therefore, you have to consider the probability of each. So if we look at this, the probability of green, so let's say the question says, what are the chances, or what is the probability, I should say, what is the probability of getting 2 green marbles? All right. For example, what is the probability when you're taking out of this box, getting 2 green marbles out of it? So if we remember, the probability of the first probability, the first one, is going to be the probability of getting 1 green marble. All right. So it's going to be, what is the probability in this case? We have 2 green marbles. So we're going to be choosing from 2 divided by, what is our total sample space? It's 5. All right. So this is of getting 1 green marble. The second thing is getting another green marble again. However, now our sample has changed because we have already took one green marble and without replacement. Okay, so this is without replacement, meaning we did not put back any marbles. So now our sample size has changed. Now we are left with only one green marble inside, and the total is 4. So the probability of green marble the second time, this is the first time, this is going to be equal to 1. Now we have only one marble, one green marble, and our sample has become 4. All right. So this is where you will be using P of A intersection B is equal to P of A times P of B. All right. P of B, sorry, conditional A. So what this means is this is our P of A, and this is our P of B after A has occurred. So this P of A is our first probability that we are going to get the first time. The P of B is our second probability after A has happened. So this is what is meant by conditional probability. So when we want to put this in the equation, it is going to be 2 over 5. It's going to be equal to 2 over 5 times 1 over 4, which is going to be equal to 2 over 20 or 1 over 10. So it's equal to 0.1 or 10% chance. All right. There's a 10% chance of getting 2 green marbles without replacement. All right. This is what they call a dependent event. Dependent event. All right. Because there's a conditional probability. Now, what about the case of an independent event? So if we have the same exact case here, where we have the same marbles, but there is replacement. So the question here is now with replacement. The same question. What's the probability of getting 2 green marbles? Okay. If we look here, now, since we are replacing it, we are taking one marble and we're putting it back again, and we want to see our chance of getting a green marble again. This case now, we do not have any conditional probability. Why is that? Because if you notice here, if I just copy paste this down here a bit. So our first time, this is our sample size of 5 marbles. The second time again, all right, we have the exact same marbles here inside this box again. So our sample has not changed at all. Our sample space has not changed at all. We still have 2 green marbles here. We still have 2 green marbles here. So in other words, in an independent event, this is what they call an independent event. Why? Because there is replacement with replacement. So without replacement will be dependent. With replacement will be independent. All right? So in this case, we can say that the P of B conditional A is simply going to be P of B. Why is that? Because the event of B no longer depends on the event of A. And it doesn't matter what we pick the first time, then it is being replaced. So in the second time here, we have the exact same sample space and the exact same what you call it, the exact same number of green marbles. All right. Now, how are we going to do this? We're going to do the exact same equation again. So it's going to be P, A, and B. So events A and B occurring, or we could say P of A intersection B. It's the same thing. Remember, and is basically P, A, and B is equal to P of A times straight up P of B, because this is an independent event. All right. This does not get affected by A. So we're just going to take the values again. We have 2 green out of 5 times 2 green out of 5. Multiply that, we're going to get 4 out of 25. All right. This is going to be the probability now, which is equal to 0.16 or 16% chance. If you notice, this number is a bit larger, which makes sense because we still have 2 green balls to choose from here. So we still have a higher chance of getting a green ball again. In this case here, we were left with only one green ball. That's why the probability is a bit lower. So there's only a 10% chance if you're not replacing, but there's a 16% chance if there is replacement. All right. So let's solve this using the one of the tree diagrams that we did earlier. Let me try to find it. All right. Okay. So let's look at this question. Okay. A stationery store sells a box of highlighters that contain 4 yellow and 3 blue highlighters. All right. 2 highlighters were picked randomly without replacement. As soon as you see without replacement, you know that this is a dependent event. This is dependent, so we're going to have to use conditional probability. Basically, the second choice is going to affect, or the next choice is going to affect our first choice. So complete the tree diagram probability. If you remember, the initial probability, we have to just find it out normally. So the store sells a box of highlighters, contains 4 yellow and 3 blue. So we have 4 yellow. I'm going to write it in orange. So 4 yellow, and we have 3 blue. So our total sample space is equal to 7. We have a total of 7 highlighters we can choose from. Initially, this is our first pick. This is our first, and then this is our second. All right. So this is our first, and this is our second. So the first pick is going to be out of the 7. So we know that this is going to be over 7 and over 7. For the yellow, there's going to be 4 yellow. So it's going to be 4 over 7. For the blue, it is going to be 3 out of 7. Now, after picking a yellow highlighter, all right, if we choose a first one to be a yellow highlighter, how many more yellows are left? Now here in this case, for this case, all right, we will be left with 3 yellow and 3 blue. So our sample space is now 6. Same thing here. If we choose a blue one, we will be left with 2 blue and 3 yellow. And 4 yellow, sorry. We have a total of 4. So 4 yellow, because we already only chose blue. So the yellow is still in the box. So n of s is going to be also equal to 6. The number of sample sizes will be the same, but here we have less yellow, here we have less blue. So this is what we're going to be using now to put in our second probability. So what is the chance of getting another yellow again? It is going to be, now we have 3 yellow, and our sample size is now 6. Same thing at the bottom. Now we have 3 blue. Our sample size is still 6. Okay. So this is the probability of getting 2 yellows in a row. This is the probability of getting yellow and blue. And the bottom part of the tree, what is the chance of getting yellow now? We have 4 yellows still in the box, but our sample size has become 6. And here now we only have 2 blues left in the box, and our sample size is also 6. Okay. So when it comes to doing the multiplication here, this is going to be 4 over 7 times 3 over 6. Okay, we're just multiplying. This is all we're going to do now. We're just going to be multiplying the first number with the second number, like I explained before. For yellow and blue, we're going to be multiplying 4 over 7 by 3 over 6. Here, here for this one, for the blue line now, for the bottom line, we're going to be multiplying 3 over 7 first by 4 over 6 for yellow, and then we're going to be doing again 3 over 7 by 2 over 6 for blue. And this is how you will be solving for all your conditional probabilities, or your AND probabilities, your intersection probabilities, also known as the joint probability, depending on your first highlighter and your second highlighter. All right. Remember, when you have it without replacement, you're going to be doing it in this way. If there is replacement, then it will stay the same. Okay, there is no conditional probability. This is the whole idea. Okay, let's solve another question. So, for example, here, one of the questions says, what is the probability, just to get an idea how a question might come. It says, what is the probability of randomly picking the first blue and then one yellow highlighter? So basically, we are looking for P of blue and yellow. So we're going to look at the blue and yellow. Where is B and Y? It's this one. So it's going to be equal to 3/7 times 4/6, which is equal to 3 times 4 divided by 7 times 6. It's going to be 2/7. So this is your probability, or this is equal to 0.29 or 29% chance. Okay, this is how you will find the probability of that. Let's look at another example of this. So a purse contains 5 10 BDs and 7 20 BDs. Okay, 2 bills are selected without the first selection being replaced. So no replacement. Basically, this means that there's going to be a conditional probability because they are dependent. Okay, no replacement. Again, we're going to look at what we have. So we have 5. So our first one, event A, okay, the number of things in A, number of 10 BDs, all right, so A is for 10 BDs, is 5. B, the number of 20 BDs is 7. 20 BDs, 7, all right? Or in other words, we can say that this is the N, the cardinality of the sets, all right? So 2 bills were selected without the first selection being replaced. So it is happening 2 times, okay? Find P of, they want us to find P of the 10 BD, which is A, and the 20 BD, which is B. Now remember, since this is a conditional, this equation is going to be equal to P of A times P of B after A has occurred. So if we're going to find this out, we know that our N of the sample is equal to 5 plus 7, which is 12. The total number of bills is 12. And then we're going to look at each one separately. So P of A is going to be equal to 5/12. All right. So this is basically saying we are selecting A first, which is 5/12. And the chances of B occurring after A is occurring is equal to 7/12 minus 1. So it's 11. Why? Because here n of s for second is equal to 11. After this has been selected, after a bill has been selected, now the sample space has become reduced. Again, this says BHD 10 and then BHD 20. So the first selection is a 10 BD, and then the second selection is 20 BD. All right? So this is going to give us P of A and B is equal to 5/12 times 7/11. Okay? So just put that in the calculator. So this is going to be equal to 35/132, which is 0.27 or 27% chance. Okay? A few things here to note, all right? P of A and B, okay? P of A and B is going to be the same as saying if A occurred after B times probability of B. What does this mean? Yani, we can say either that A is occurring first and then the second one is this, Or the same thing can be said about B is occurring first and then A is occurring after B. We can always swap between these two. It is the same meaning. So if we solve it this way, we were going to get 7 over 12 times 5 over 11. If you notice, it is the exact same equation. You're going to be getting 35 over 132. Okay? So PA conditional B times P of B is the same as saying P of A times PB condition of A. So if I rearrange this equation, you will notice that P of A condition B is equal to, if I just take this PB and put it down here, it is going to be equal to P of A and B over P of B. The same thing can be said about P of B conditional A is going to be equal to P of A and B over P of A. Okay, this is just rearranging the formula here. This formula, which is PA and B is equal to PA times PBA. So this is what we will call conditional probability, this over here. This is how you will find conditional probability. All right? Is this clear? Anyone has any questions so far? Okay. So your question is, why did we take 5 and 7? Remember, here, this is just a 10 BD note. يعني احنا we're not looking at the cost or at the price, all right? We are looking at the number of, so like let's say this is the bag. We have a bag, all right? We have 1, 2, 3, 4, 5, 10 BDs, okay? The green boxes are 10 BD. And then we have 1, 2, 3, 4, 5, 6, 7, and this is the 20 BDs. This is just the type of note it is. And it's a 20 BD note or a 10 BD note. We don't care about the actual price or the value of these. We care about the number of these, how many of them are available in this purse or in this bag. That's why we are looking at the total number. Remember, when you are selecting, يعني يوم تحطون ايدكم في الصندوق ما بيتغير السعر. It's either going to be a 10 or it's going to be a 20. That is what is meant by that. But how many 10 BDs do you have? Yani how many in your purse, how many 10 BDs do you have? That's what is going to affect. If you have only one 10 BD note, it's different than having 10 10 BD notes. We don't care about the actual pricing of it. We don't care about how much it costs. زين؟ يعني think of it as if they're balls. If you have 10 green ball, 5 green balls and or pieces of paper, and you have 7 blue pieces of paper. That is the idea. Someone else raised their hand. Can you just type your question in the chat if you have it? Is this clear, Marwa? Did this clarify the point? So when we're doing the selection, we're just looking at the number of boxes or the number of papers. So here, the number of 10s, the number of 10 BDs is 5. And the number of 20 BDs is equal to 7. This is the idea. We want to know the number of bills we have. Okay. النقطة الثانية اللي هي high conditional probability. Okay. Let me explain this one more time, the whole concept with another question so that you guys can get a better idea. Let me find a question that involves this. Let me see the worksheet. Let us use the example of marbles again, or balls. Let's do this question. And I'll explain the entire concept again, step by step. In a box with 6 red balls and 9 green balls. So we know that we have a box. We have 1, 2, 3, 4, 5, 6 red balls. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 green balls. Okay? Determine the probability of drawing 2 red marbles. Okay, so we want 2 red marbles. Then, illustrating the scenarios with a tree diagram. I'm not going to do the tree diagram. I'm just going to explain the concept with replacement. So first things first, when it says with replacement, this means independent. All right. When it is independent, the P of AB is equal to P of A, and the P of BA is equal to P of B. What does this mean? معناته A depending on B. This is what conditional probability means. When I write P of A, B, it means A is depending on B. So this is depending on each other. All right, this is what conditional probability means. So when we are saying with replacement, they are independent. That means they are no longer depending on each other. All right. In the case of independent, if independent, these are going to be equal to P of A because it doesn't matter what happens in B anymore. We do not care. So only A is going to happen regardless of what happens to B itself. يعني مو مهم شو الايفنت مال B اللي يصير لانه ما قاعد يأثر على A خير شر. That's why it's only simply going to be the probability of A. This is what that means. Okay? Now, if we want to solve this, we just apply the equation. But before that, we need to find our A's and our B's. So A is for the red marble, the P of A is for the red marble, which is equal to how many marbles we have? We have 6 or balls. We have 6 red balls over. What is our total sample space? It is 6 plus 9. We have 6 red balls plus 9 green balls. So 6 plus 9 is 15. So this is our total number, 15. And P of B is equal to how many green balls we have? We have 9 over 15. This is in the case of independent now. We're solving part A. Because they're independent of each other. Why? Because we're replacing the balls. The sample is not changing, the sample size and the sample space. The balls keep going back into this. All right? We have 6 plus 9. This is the total size. How are we going to apply the equation now? We know that the equation P of A and B is equal to the P of A and B, intersection B, which is P of A times P of B slash A. But since it is independent, this is going to be equal to P of B. Why? Because it's independent. Okay? Because B does not depend on A anymore. So it is independent. So we can simply rewrite this as P of A times P of B. So it's going to be equal to 6 over 15 times 9 over 15, which is going to be equal to 6 over 25, or you can say 0.24, which is 24%. Okay? This is what this means. This is in the case if we have replacement. Now, if I draw this again one more time now, and this case, there is no replacement. No replacement. اللي طلعناه هني, this is what they call the probability of drawing 2 red marbles. إنزين, this is basically the probability of getting 2 marbles. The total probability basically. يعني the probability of doing, لأن remember we are first pull and then second pull. So this is the probability of doing 2 red marbles. Okay? With replacement. This is what this is called. So it's 2 red marbles with replacement. Okay? Six, 6, 9, 15. Yeah. Okay? So this is what this is. Now, the second case will be, the second case 1 second, just 1 second. Let me make sure my work here is correct. Okay, I think I see my mistake here. Okay, I made a mistake here. I'll tell you what my mistake is. So again, the question is asking for 2 red marbles, okay? Here, event B, I did not consider it as red. I considered it as green. So what I solved for was 1 green and 1 red marble. So what we need to do is P of B is also going to be 6/15. Why? لأن, again, it's asking for 2 red marbles. So this is your first red marble. This is your second red marble. The reason it is 6 in both cases is because we are putting them back again. There is replacement. So we're putting them back again in our sample. All right. So it is going to be 6/15 times 6/15. My bad about that. So this is going to be 4/25, which is equal to 0.16. What I solved for earlier was if we wanted to choose 1 red and 1 green. هني السؤال, it says we want 2 red marbles. So P of A, our first event is getting a red marble, which is this probability. Our second event, again, is trying to get a red marble, but since there is replacement, there is no change in the shape or the size of the sample. So it's going to be 6/15 again. So we'll just multiply 6/15 by 6/15. Okay? This is what we tried to find. Now, if there is no replacement, first red marble, so we can be clear, okay, is going to have this sample size of 15, the same sample size, and red is going to be equal to, we have 1, 2, 3, 4, 5, 6 red marbles. Okay? Now, this is our first. Our second red ball, or red marble or ball, or whatever, we have already selected 1 red from here. So there's already 1 red outside. Okay? How much is left in our sample space? Now our sample space has changed. We have 1 less red marble, so there's only 5 red marbles. So 1 less total marble or ball, so we have 14. This is the main difference between with replacement and without replacement. هني طلعنا احنا الكرة الحمراء، فيوم نبغى نختار كرة حمراء ثانية بيكون عندنا السامبل سبيس أصغر، قلوا أرقام يعني عدد الكور الحمراء. So because of that, here we have conditional probability. This is conditional probability. Okay? Meaning that when we are going to use our equation, P of A, so P of A is basically here. We're going to get it from this. And P of B conditional A, because now P of B depends on A. P of A and B is going to be equal to P of A times P of B conditional A. Remember, event A is simply, يعني A is choosing first red marble. P of B is choosing second red marble. This is always the case. The reason there's conditionality is because we're choosing a second red marble. So P B يعني slash A, this is choosing second red marble after event A. This is what this means. This is what conditional probability means. فمعناته إن we are choosing a second marble after A has already affected it, after A has already been completed. So when we're going to solve this, P of A is going to be equal to 6 red marbles over 15. P B of A is going to be equal to, we are left with 5 red marbles and 14 total number of marbles. فإحنا الحين نبغى نطلع ال probability of choosing 2 marbles. So the probability of A and B occurring, which is choosing 2 red marbles in a row, is going to be equal to P of A times PB of A, which is equal to 6 over 15 times 5 over 14, which is equal to 6 times 5 divided by 15 times 14, which is 1 over 7. This is equal to 0.14 or 14%. Is it clear now? Is it a bit better? I will try to find one more problem to solve to clarify this a little bit. Any questions about this, about the problem I just solved before I move on? Then I want to do one with a Venn diagram because I feel like that will make it so much easier to understand and get a better idea about it. Okay. Let's do it using this Venn diagram. So if you remember Venn diagrams from before, okay, Venn diagrams, this is the set of A, this is the set of B, all right? And this is the outside the set, and this is the entire sample space. So if we're looking at n of s, we're just going to add up all the numbers inside. So it's going to be equal to 12 plus 8 plus 4 plus 9, okay? Because it has to be equal to everything that's inside the box. So we have 12 over here, A is 8 and 4, and B is 4 and 9, all right? So 4 is the common between A and B. So this is going to be equal to 12 plus 8 plus 4 plus 9. We have 33, okay? Now, since we have this P of A, remember before I do PBA, remember here that this is all of A, okay? This whole thing is A. This entire blue circle is A. So we know that n of A is equal to 8 plus 4, which is 12, all right? Because this is a whole blue circle here is the system A. So let's look at B now. We look at B. This, all of it is B. All of this is B. Then, so B, n of B is equal to 9 plus 4, which is equal to 13. Okay? So we have 13 total in B and 12 total in A, with 4 being in between of them, يعني. Okay? So 4 samples are in between them. So there is, يعني, if we want to find A intersection B, then it is going to have to do with the 4. It is going to be equal to 4. صح ولا لا? If you remember from set theory. This is just talking about basic cardinality and basic Venn diagram. Let's talk about the probability of each now. So remember that probability of A is going to be equal to the number of A over the number of the total set. So it's going to be A, which is 12, over the total set is 33. Okay? P of B is going to be equal to, again, number of B over number of set, which is equal to 13 over 33. Okay? The probability of A intersection B, again, it's the same thing. It's going to be equal to 4 over, and then, again, this is the n of A intersection B. 4 over, because this is the number. We don't know what exactly they are. We don't know the set. Remember that when we are writing it by itself, and you usually would say A is, I don't know, names or letters like heads and tails, and then tails and heads, blah, blah, blah. But we don't have all of that. We only have the probabilities, the numbers of how much it's occurring. So we're always talking about the numbers in this case. So n of A and B is equal to 4. اللي في النص, the intersection here. All right? This part is this part. this is the blue, and this is the green. Then, so the intersection itself is equal to 4 over, again, the entire sample space is 33. This is just the total sample space. So remember again when we were doing the equation, P of A and B, which is equal to P of A intersection B, is P of A times P of B when A occurs. Okay? For independent events, remember this is just going to be P of B, but this is not an independent event. Okay? Because we have because it is asking for us to calculate PB of A. So we have a conditional, and there always will be a conditional if there's an intersection in between these two. Okay? Now, what about this? This is also going to be equal to, I'm just going to re-explain a concept from earlier, P of B times P of A occurring after B is occurring. And then, same concept again. Now, this is the equation we are used to, but we can also rearrange this equation. Let's look at the first equation. Let's look at the first equation. We're going to just do some simple math, okay? So if we divide both sides, by P, B of A, or let's divide it by P of A, okay? And divide this side by P of A. You will notice that P of A and P of A will cancel here. So what we will remain with is P, B, A is equal to P, A intersection B over P of A. That's it. Simply, this is what they call conditional probability. So this is the equation for it. So as you can see, it's the same as the equation that we are using, the intersection or the joint equation, which is A and B. To find the conditional probability directly, if you have the other givens, you will just do the opposite, where you will take PB of A on one side, and you will substitute the values for this. So in this case, we already have found out that PA intersection B is 4 over 33. 4 over 33, right? And this is the probability, which is over here, right? This is the probability of A intersection B. The probability of A, we already calculated early on. It's just 12 over 33. 12 over 33. So we're going to put 12 over 33 down here. Okay? Yeah, this was orange. Then, now, we simplify this in the calculator, all right? Or you can directly, if you know how to do your math really well, you're going to cancel these 33s. It's going to be 4 over 12, which is 1 over 3. And this is your probability or your conditional probability of B occurring after A has occurred, okay? Using a Venn diagram, if you are given a Venn diagram. Tamam? Is this clear? I know it's a lot of concepts mixed together. It's a lot of things, but again, the main equation you need to know is this, okay, where you have an intersection, you're going to have the probability of A, and you're going to have to multiply by the conditional probability of the other one. In the case of dependent, this exists. In the case of independent, this is just simply equal to P of B. شنو الفرق بين PA and B, PA or B, و PA union B؟ أول شيء we have P of A or B. This is simply equal to PA union B. These are the same thing, okay? Then we have P of A and B. This is equal to P of A intersection B. Tamam? This is the first thing you need to know. Or and union is the same thing. And an intersection is the same thing. Now, When do you use and when are you going to use or? Okay, so if I can find an older question from or, عشان I just show you the differences. Let's see. Let's take something simpler. Something like, okay, this is normal probability. When did we start union? I think here, la. Seeing all the probabilities, week 4 or week 3. 1 second, let me just double check. Let me use an example from what I solved the previous weeks. Is it here? Uh, 1 second. This is just basic probability. When did I start teaching union? Was it in part A here? No. Any. Did I do an example using union? Yeah, okay. So we have this question here for this one, okay? And then we solved the question early on here for the other one, which is very similar again. Because this is very important to understand the difference between these two. Then, so here in this question, when we're looking at or, they are literally telling you that calculate the probability that the marble drawn is yellow or red. Yellow or red. So they are mentioning P of yellow or red. Okay. So basically, this means that you have a selection between the two. You can choose either yellow or red. You don't have both yellow and red. In this case, they are saying determine the probability of drawing two red marbles, meaning that you are going to draw a red marble and another red marble. So you're going to be able to find it from the meaning of the question. So in this question here, it mentions calculate the probability you draw a yellow or a red marble. Here in this case, it is saying that you are drawing two red marbles in a row. فبيكون عندكم red marble و another red marble. So and we're going to have both of these. So this and this. In this case, you're going to be drawing either one yellow or one red. This is how you will be able to differentiate between or, which is union, and, which is intersection. It depends on how the question is being asked. Okay? Does this clarify a bit, Bayan Yani, the difference between and or? It depends on how the question is being phrased. It depends on what you're trying to find out. Tamam? Let me see if there's any more questions I can solve about this عشان بس أوضح الفكرة a bit more. Let's do more Venn diagram questions actually. Then let's do this one. We have a Venn diagram here. Okay. The question says a spinner with 8 equal parts numbered 1 to 8 is spun. The spinner lands on an odd number is event A. Okay. So if you notice, we have 1, 3 is the odd number here, and A, 5, 7. These are all a part of A. The spinner lands on a number which is greater than 4. Any number greater than 4 is 5, 6, 7, 8. Okay. So again, if we write this down, we will write it down in a bit, but this means this is greater than 4. So if you notice here, 5, 6, 7, 8 is in part B. These are all great. In common, the intersection you will notice is 5 and 7. And then the numbers that are outside A and B is number 2 and number 4, because number 2 is not greater than 4 and it's not odd. And 4 is not greater than 4 and it's not odd. So it's not part of A or B. So the first question says sample space. What is the sample space here? So we have 1, 2, 3, 4, 5, 6, 7, and 8. Okay? This is our sample space. We have 1, 2, 3, 4, 5, 6, 7, 8. All the numbers inside here. It says, what is event A? A is 1, 3, 5, 7. That is event A. What is event not A? Or this can be written as A naught. What is event not A? Remember, not A is everything outside the circle of A. So for the case of not A, we are going to be looking at all the numbers that are outside the circle. So the 8, the 6, the 4, and the 2. These are all not A. So it's equal to 2, 4, 6, and 8. These are all not A. And it makes sense. Why? Because A is odd numbers. Not A are going to be all the even numbers. So not odd is even. Okay? So this is how it is. Now, event B, what is event B? Event B is everything inside of B, which is 5, 7, 8, and 6. So event B is 5, 6, 7, 8. Remember, these are all the numbers that are larger than 4. So it's 5, 6, 7, 8. So it's right. What is A intersection of B equal to? A intersection of B here is equal to 5 and 7, because intersection, remember, intersection is where they are overlapping. This is intersection. Okay? So this is your intersection, 5 and 7. Okay? A and B is 5 and 7. A intersection B is 5 and 7, or A and B is 5 and 7. Okay? Keep in mind, we're not doing any probabilities so far. We are just writing the samples. We're not even looking at the number of sample spaces or the cardinality. We're literally just writing the samples now. The other question says, what is A union B? So A union B, remember, A union B is basically everything that is between A and B. Okay, everything that is between A and B. And remember, if you're looking at it from here, it should not be repeated. So the 5 and 7 are repeated values. We're only going to write them once. Okay, this 5 and 7 because it's common in between them. So A union B is 1, 3, 5, 6, 7, and 8. It is all the values inside A and B together. That is union. So intersection is whatever they have common. Union is all the values. All right? This is just the common. And this is all, everything. Okay? Inside. All inside. A and B. Okay? All of inside A and B. I'm not going to put the letter and. I'm just going to say all inside A, B. Okay? Now, the question says a number that is even but not greater than 4. So the question says find a number that is even but it is not greater than 4. So let's look at this. What is an even number that is not greater than 4? We have the number 2 and that's it, because the even numbers are 2, 4, 6, and 8. 2 is the only number that is not larger than 4. So the answer to this is going to be 2. Okay? Let's call this C, for example. Okay? Where C is a number that is even but not greater than 4. So only we have the number 2. The last question says, find the probability of A union B. Again, very simple. Now that we have the samples, it is directly in front of us. We can find out all the values directly. So you know that PA union B is going to be just simply equal to N of A union B over n of the total sample space. The reason I'm using this equation now, because remember, probability is always just probability of any event, okay, is the probability of it occurring. So the number of it occurring over the total number. That's all it is, okay? I know we are usually doing PA plus PB minus P intersection B. We can do that again. It is not wrong. But in this case, since we already have determined A union B, we can directly just find it. And we will check using that method. So A union B, what is the number of it? We have 1, 2, 3, 4, 5, 6. So N A union B is equal to 6 because we have 6 values inside. So it's going to be 6 over, what was the n of our sample space? We never found it. So n of our sample space here. So n of S is equal to 1, 2, 3, 4, 5, 6, 7, 8. We have 8 values. All right. So it's 6 over 8, which is equal to 6 over 8, which is equal to 3 over 4 or 0.75. All right. So 75% chance. Let's check this. Let's check this using the formula that we know about A union B. A union B is simply equal to P of A plus P of B minus P of A intersection B. Okay? So let's determine all of these. P of A is equal to how much? We know we have already our set A. N of A is equal to 1, 2, 3, 4. N of B is equal to 1, 2, 3, 4. And N of A intersection B is 2. A and B. N of A intersection B is equal to 2. Okay? We have two values here. So if we find these, so PA was 4 over 8. Remember, 8 is our total sample space, so it's equal to half. P of B is equal to half as well, 4 over 8, which is equal to half. And P of A intersection B, remember simply, this is going to be N of A intersection B over N of our sample space. This is always correct for any probability you find, okay? It is always going to be the number of times this is occurring over the total number. So this is equal to, we found NA intersection B, which is 2, over, what is the sample space? 8. So this is equal to 1 over 4. Let's plug this all back into our equation. So PA union B is equal to half plus half minus 1 over 4. Half plus half is 1. So 1 minus 1 over 4, which is equal to 3 over 4 or 0.75 or 75%. If you notice, we get the exact same answer, and we have to because it's the same thing. We're finding the probability of A union B. This is just the method in case if you do not have the actual values, you do not have your sample sizes, okay, like your sample space and all of that. You only have the numbers, the values, if you are given probabilities, or you can find probabilities directly, or if you're given your cardinality, the number of times it's happening. In this case, they gave us everything from the beginning in this Venn diagram. That's why we can do it the short way. If you notice here, it's just one line to find A union B. It is simply just the number of times A union B is occurring. So we have 6, the cardinality, over the total sample space. But to check, we just wanted to use this equation to show you that this equation also works. Remember, PA intersection B is working here because we have an intersection in between them. They are intersecting, all right? And this A intersection B is the same thing as saying PA intersection B if we have probability. We found it here. It is 1 over 4. So if I add an extra question to this, what is the conditional probability of A after B is occurring? Remember the equation? The equation is P of A intersection B divided by P of B. Remember, this, we got it from which equation? We got it from this equation, which is PA intersection B is equal to P of A, or in this case, P of B, times P of A after B has occurred. Okay? This equation can also be written as P intersection B is equal to P of A times P of B after A has occurred. لأن if A is occurring then B happens, or B is occurring then A happens, it's the same. It's the same thing. Okay? It's the same probability. When it comes to probability, at least it's the same thing when using it in this equation. Okay? So when we're finding conditional probability, it has come from simply just rearranging this equation. We have already found the probability of A intersection B and P of B. So we can simply just do this is equal to, what's the probability A intersection B? It's 1 over 4. Divided, what was the probability of B? It is 1 over 2. So a quarter divided by a half is simply equal to a half, which is 50%, or 0.5, which is 50%. Okay? That's basically it. This is how you'll find the conditional probability. Then, in the case of BA, remember, BA and AB are not usually equal, but in this case, they're going to be equal. Why? Because we have the same sizes for A and B. They're the same sample sizes. Because N of A and N of B are equal. So when N of A and N of B is equal, the conditional probabilities are going to be equal. But the solving will be the exact same way. It will be A intersection B over P of A. Remember that P AB is usually not necessarily equal to P of BA. All right? Sometimes. I should say sometimes, because it depends on the probability, the chance. Here we have a 50-50 chance, so it's normal that P of A of B is going to be 50%, so PB of A is going to be 50%, 50-50. But in the cases, in normal cases, in usual cases, do not equate these to each other. And do not say, oh, I have PA of B, and I'm going to just make it equal. Just because it is in this case, it doesn't mean it's always the same. Okay? Is my explanation for the Venn clear? Again, PA of B معناته this is conditional probability. The naming of it is called conditional probability. Why is it called this? Because it is a condition. There is a condition for A to occur after B is occurring. So معناته event A will occur depending on after event B is occurring. So depending on what happens with event B. This is what this means. The same thing here, but in the opposite way. So event B will occur depending on what happens with event A initially. Okay? That's basically it. Let's solve another Venn diagram question. Again, this with more, okay, this is a good one. With more practice, the better you will get at it, obviously. So, yeah. Let us see this question. So for this Venn diagram, the question says, use the Venn diagram below to answer the following questions. Okay, and they said also given n of s is equal to, FYI, this is just question 5. Okay, n of s is given to be equal to 120. So in other words, when you add up all of these numbers, you are supposed to get 120. So يعني they didn't have to give you this, but they made it easier for you guys so that you don't have to do the calculation. Because why? If you notice, they didn't give you whatever is in the outside area. There should be a number here as well. There should be a specific number outside, but they didn't give you this. So it is given that the sample space here is 120 in total. If you add all of these up, let's just see. So it's 8 plus 10 plus 2 plus 7 plus 24 plus 15 plus 14. Okay, so when we're adding all of these up, adding all will be equal to 80. So what does this show us? This shows us that there's a number 40 outside as well. Okay, this isn't a part of the question. This is just how you should analyze it. Okay, so 40 is outside. Now, Let's look at the questions they're asking about this. Again, how did I get the 40? It's just n of s minus this 80 over here, all. So it's equal to 120 minus 80, which is just simply equal to 40. This is how much is remaining from the sample space. And since they're not inside any of these Venn diagrams, it has to be in the outside space, okay? This is just an extra concept. It's not a part of the question. I just want you guys to understand it, all right? Now, let's compute P of F. That is the first question. Compute P of F, all right? The probability of, so we have F, G, and H. We are, first things first, let me copy paste this down one more time. Let us find out all our sample sizes. So we know F, N of F. Remember here, these numbers are sample size numbers. This isn't the same as the previous example. The previous example mentioned that these are roles. So these are the actual sample space values. They're not the N of S. This is the actual parts of S. Here we are talking about N of S. So here we're just talking about the values, the cardinality of each. Yani how many numbers of items are available within F, within G, within H. Okay? N of F, we're simply just going to add all the numbers. So 8 plus 10 plus 2 plus 7. We're adding all the numbers that are within this circle. Okay? This circle here of F, we're just adding all the numbers inside of it. Okay? This is what we are doing. So this is N of F. It is equal to 8 plus 10 plus 2 plus 7, which is 27. Okay? Let's find N of G and N of H as well. So N of G is going to be equal to, let's look at the purple, the green circle now, which is G. This is G. Okay? So again, remember, this is the circle. And everything inside the circle is going to be a part of G. So N of G is equal to 10 plus 2 plus 15 plus 24, which is equal to 10 plus 2 plus 15 plus 24 is 51. And finally, let's find N of H, which is equal to, again, let's make it purple. Okay, this is our H value. Everything inside the purple circle is our H. So if we're looking at it, we have 2 plus 7 plus 15 plus 14. So it's equal to 2 plus 7 plus 15 plus 14, 38. Okay? So now we have found our N of F, N of G, and N of H. Okay? Now we can start solving the question. No matter what the question is, we can solve it because we have all these values. So we can find the probability of F, we can find the probability of G, and we can find the probability of H. And we know that N of S is equal to 120, given in the question. Question A, part A says compute P of F. So simple. A is asking for P of F, which is equal to N of F divided by the number of the sample space, which is 27 over 120. Simplify this, it's 27 by 120, it's 9 over 40 or 0.225 or 22.5%. Okay. Simple, very straightforward. You guys should already be familiar with this. Part B says, زين. Okay. ليش هني جمعت الأرقام والمسألة اللي قبلتها حسبتها كعناصر؟ Again, it depends on the question. Here, the question is mentioning إن there's a spinner with 8 equal parts. So هني, this is showing you the elements. This isn't showing you the numbers, the cardinality. This is showing you the elements, this Venn diagram. And it is explained that in the question. If it's not explained in the question, معناته this is showing you cardinality. But since this is showing, it says the Venn diagram shows the outcomes and events A and B of this experiment, clearly mentioned here. Okay? Yani since it is saying this part, A and B, events A and B, it's showing that معناته these are the actual outcomes, the actual value, not the cardinality, not the number of times it is happening. زين? In this question, it doesn't mention that. When it doesn't mention it, معناته instantly you should know that this is just talking about the frequency or the cardinality of how many times it's happening. 8 times, 10 times, 2 times, that's what it means. It depends on the question. If the question clarifies it, know that it is going to be events. If it doesn't, it is just the numbers and the cardinality of it. Okay? Moving on. Part B says compute P of G or H. So we want P of G or H. This is also equal to P of G union H. Okay? One of two ways you can solve this. You can either, actually, no, here we do not have the sample, we have the sample sizes only. So the best way to solve this is, yeah, actually, you have one of two ways you can solve this. You can either do N of GUH over N of the sample size. Yani, you're going to find GUH, you're going to do G union H here, find the values and all of that, but it will get very complicated. So it is much better to just simply use the formula that we know, which is P of G plus P of UH minus P of G intersection of H. Okay, and we can simply find it this way. So we need to find P of G. P of G is going to be equal to 51 over the total sample space of 120. So it's equal to 51 over 120, which is 17 over 40, which is also equal to 0.425 or 42.5%. Okay. P of H is equal to, what did we get for H? 38. So this is from the green part here, it's 51. And this is 38 over here. And for F earlier, we used the orange part, which is 27. Okay. Just so you guys know where I got these numbers from. 38 over 120, which is equal to, when you divide 38 by 120, you get 19 over 60, or it's equal to 0.317 or 31.7%. Usually, I personally like to deal with fractions when we're adding and multiplying until the final answer, but I'm just putting them all here so you guys can just see what it looks like. So now we can just plug into the equation, but first we need to find the probability of G and H. To do that, first we need to find G and H. All right? What is G and H equal to? If we go back to our, or N of G and H. We cannot find G and H directly because we don't have samples, but we have the sizes of the samples. So we know that G and H is going to be this intersection over here. What color did I not use? Let's use red. So G, H, what is in common between them? Where are they overlapping? We're only looking at the green and purple circles, okay? So this is the overlapping part. Let me actually do it in blue. This is the overlapping part, okay, between the purple circle and the green circle. So this is the intersection of G and H, which is 2 plus 15. So N here is going to be equal to 2 plus 15, which is equal to 17. Again, let me explain this point. Just like we did earlier for N of F and N of G and N of H, we were adding everything that is inside of it. We are going to do the same exact thing for this location, because remember, this location is the intersection between G and H. We do not have the samples itself, but we have the sample size. That's why we are adding. So we have 15 plus 2 in total. That's why the N of G and H is going to be equal to 17. So now, to find the probability of G and H, let's move this a bit up. To find the probability of G and H, it is equal to the probability, the number or the cardinality of G and H over the cardinality of the sample space. So this is going to be equal to 17 over 120. Okay? 17 over 120. If I simplify this, 17 divided by 120 is going to be equal to 0.142 or 14.2%. Okay, all the same thing. So now that we have the probability of G, the probability of H, and the probability of G intersection with H, we can just plug it all into this equation. So P of G or H is equal to this probability here, 51 over 120, 51 over 120 plus 38 over 120, okay, plus this minus 17 over 120, okay? And we can find the final answer. This is going to be equal to minus 17, 72 over 120, which is also equal to 3 over 5, or 60%, which is 0.6, which is 60%. So the probability of G or H is 60%, okay, or 0.6. Here now it says compute the probability of F and G. Of F and G. Remember and, okay? We can simply find this by finding the number of F and G over N of the sample size. Okay? This is how you can find it. How do we do that? Again, very straightforward. We go and look at where's the intersection between F and G. Let's highlight it with orange, or actually let's highlight it with red. So F and G is this part over here. 1 second. So F and G is everything between this highlighted part over here. All right. So it's the 10 and the 2. Okay. That is what this is. So it's this part from here all the way till here. So we're just simply going to add 10 plus 2 to find the N of F and G. So it's equal to 10 plus 2 divided by the total sample size, which is 120. It's equal to 12 over 120, which is 1 over 10, or 10%. Okay, 1 over 10 is equal to 0.1. The last question says, are F and G dependent or independent? Then, what does that mean? F and G are dependent or independent. How do we know if something is dependent or independent? We're using conditional probability. Okay, this is for part D. This was part C. This is a very important concept. So remember that when we have an independent event, the conditional probability of B, A, for example, is going to be equal to the probability of B. Or in this case, let's stick with this case. So they're asking about F and G. So F occurring after G has to be equal to the probability of F. And the probability of G occurring after F has to be equal to the probability of G. Right? This is in the case of an independent event. All right? When we have an independent event, this is how we know. So how can we check if something is dependent? If the opposite is true. So if PF of G is not equal to P of F, and PG of F, or PG after F, or occurring after F, is not equal to P of G. Obviously, you could just solve one of these equations, but both can be used to solve this. So let us determine this. So remember, what was conditional probability? Pf of G is equal to P of A. Let me start from the beginning, عشان you guys know where I'm getting all of this. So P of A of F intersection G is equal to P of F, or P of G, it doesn't matter, times the probability of G occurring after F. Okay? Let's solve for PGF. So if we do that, we have to divide both sides by P of F. by P of F. This P of F will cancel over here, and we will remain with the conditional probability GF is equal to P of F intersection G over P of F. Okay? F and G, or F intersection G, we have already found it. So this, I wrote it as and, this is also intersection. So this is intersection. Okay? So we already know the probability of F and G, which is equal to 0.1. 0.1. Okay? And we have already calculated the probability of F earlier, which is 0.225. 0.225. So we're going to find out that G of F now is equal to 0.1 divided by 0.225 is equal to 4 over 9, or 0.444, or 44.4%. Okay? This is the probability we found for GF. Now, the question wants us to determine whether these are dependent or independent. How can we check? We should see if PG of F, we have to ask ourselves, is PG of F equal to P of G? This is the question we're going to ask ourselves. So what is the value for this? This is 0.444. And what is the value of this? Let's see. We've calculated P of G earlier. It is equal to 0.425. 0.425. So you notice that these two are not equal. This is not equal to this. Therefore, these two are dependent events. Is this clear? Again, recap. For two events to be independent, we know that their conditional probability will simply be just equal to the same probability, because F depending on G does not matter in an independent event because they don't depend on each other. So it's simply P of F. In this case, it will be independent. But now, when we did this solving, when we found PG of F, we found that it is not equal to P of G. Therefore, these two are considered dependent events. Okay? Is this clear so far? Anyone has any questions? Okay. I want to start with discrete, and if you have any questions, feel free to ask. I'm not going to move on unless this is very clear, because this is a very important concept for probability. Knowing how to use all these conditional probabilities, knowing when to use and, knowing how union works, knowing how to decipher it from a Venn diagram. These are very important. Lena, if you guys don't know how to deal with it here, when you go to binomial and normal distribution, you guys must already know how to do this. Hashan, you can move on with binomial and normal distribution. That's why I want to make sure that this concept is very clear. Lena, normal and binomial, they're just equations and you plug in. That's it. Really, they're just equations and you're going to be plugging in. I'm going to give very little theory when we go to that. Okay? Okay. Let me solve a few more of this before. Actually, if no one has any questions, I want to start very al-khafif with discrete and non-discrete. Just so you guys get a basic concept, so that next session, inshallah, on Monday, I can go directly into binomial and normal distributions. Then obviously, they're going to be related. But just give me 5 minutes. I'll take a break just to gather my voice. And we're gonna start, inshallah, with discrete and continuation. If you have any questions now, please feel free to ask. All right. So moving on to discrete random variables and continuous random variables. Okay. What does that mean? When we use the word discrete in math in general, especially when it comes to probability and statistics, okay, discrete basically means one variable, or basically it is not continuous. Yani, the best way to explain this is using a graph. So when you have a value, and then the probability of that is going to look like this. It's a bar. It's a single bar. It's a single value, 1, 2, 3, like that. Okay. It is not going on between a specific range. So a discrete variable, for example, is a flip of a coin. Okay. It can either be heads or tails. So this is what is meant by a discrete variable. So you can get either heads or tails. Or for example, if we say you're flipping two coins, you can either get head or head tails or tail head or tail. Again, this is just you get a specific value, a discrete value for each one. This is what is meant by a discrete variable. Okay. So for a discrete variable, let's simply just keep using this same example, a coin, so that you guys can get the idea. Let's go over some notations you will see. So the way you would usually describe the probability distribution of a discrete variable, Zain, you will be writing it in this form. P of x equals something. Usually they write it as small x. Okay. What does this mean? This means that you have something unknown. We don't know what it is when it's capital. And this is a known value, a value that we know. All right. For example, and obviously the probability has to be between 0 and 1. You guys should know that by now. So for example, let's say that we have heads and tails. Okay. So our sample is going to look like this. It's heads or tails. Okay. So for x, the way we would write it in x terms, so our x's is going to be either true, 0, or false, or true. Okay, 0 or 1. It can either be heads or tails. So our number of heads, the possible for number of heads, if you notice here, we can either get it as tails, which is 0, or we can get it as heads, which is 1 head in this case. Okay, so this is basically saying the number of heads. We're saying that x is the number of heads we're getting. All right? So we can either get it as a 0, as in there's no heads at all, or we can get it as a 1 where there is a head. This is what is meant by this capital X. So if we want to apply this probability to it, this probability distribution, it's going to be X is equal to 0. And then we also have P of 1X is equal to 1. So these are the cases when it's 0 and 1. Again, 0, this means no heads. 1 means there is heads. Right? And you will get a better idea the more we solve questions. But this is in the case of flipping one coin. So it can either be heads or tails. So it can be either no heads or heads. So how can we find the probability here? So this is P of x equal to 0. In other words, we can say this is the small p of 0. All right. Or we could simply say this is the p of no head. It's the same thing because 0 is no head. Here, this, if we are relating it to our sample space, S, when do we get no head? So S is H and T. What is the probability of getting no head? So the probability of getting no head is basically the probability of getting tails, which is 1 over 2. This is what this means. This is basically the probability of getting no head, or the probability of getting tails, which is equal to half. The same thing can be for x equal 1. It is going to be the probability of 1, which is equal to the probability of getting head. Or in other words, we can say it's the probability of getting h, which is also half in this case. All right? This is the basic way of just notation of how you would write it. But now let's look at an example of flipping two coins. So here, flipping twice. Our sample space now is going to be heads, 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 tails, tails, heads, and then tails, tails. All right? So now, if I'm saying what is the probability of getting two heads? Because we're flipping twice. So the first flip is heads and the second second flip is head as well. So our x in this case is going to be equal to, okay? X is our random variable, okay? This is just the notation of a random variable, okay? What is it going to be? You can either get no heads. So if we look at here, we have the situation of getting 0 heads. So we have 0. Then we have the chance of getting one head, which is here and here. So one head. And then there's the chance of getting two heads, which is here. 2. Okay? This is what the x basically represents. How many times of it? What is the range of possible solutions or random variables for the getting of two heads in this example? All right. So this is 0 heads. This is 1 head over here, and this is 2 heads. These are the possibilities. Yani these are all the possibilities that we can get. Okay. So if we want to do this now in the way of the same way of solving earlier, so remember P of x is equal to x like this. So P of x is equal to x. Again, this is the same thing. The small x here, this is what it is meant by the small x. It is one of these values. All right. So this is what is determined by x. X is a known variable, a known value. Actually, it's not a variable, known value. All right. So x, the large x is our random variable, and the small x, this is just notation, the way they define things. So if we want to go now step by step, let's see for x is equal to 0. All right. X is equal to 0 is the same as saying P of x or P of no head. No head. Or simply, this is P of getting T and another T, right? Because remember, we have two flips. So the first flip is going to be tails, and the second flip is going to be tails. So it's a P of T and T. And we already know that P of T and T is simply P of T times P of T, which is equal to, remember, there's no conditional probability here because these are independent events. These events are independent. When you flip a coin, you can flip it again, and it has nothing to do with the first flip. They do not depend on each other. So it is going to be P of T. What is the chance? It's 1 over 2 times 1 over 2. Okay, which is equal to 1 over 4. Again, why is this the case? Because if we find our probability of T here, what is the probability of T? How many times, how can we get, what is the possibility of getting tails out of this? It is 1 over 2. When you're flipping a coin one time, all right? We're not looking at the full sample space. We're looking at only one flip. So here, when we're calculating P of T, it's for one flip in this case. That's the whole idea. The whole idea here is we're looking at one basic flip, and then it doesn't matter if it's happening 10 times, 1,000 times. We're just looking at one flip, and then we're going to be using that to determine no matter how many thousand times of flips using the discrete formula. And we will look at that in a bit. So P of T for one flip is, remember, we have a sample space of heads or tails. So it's 1 over 2. All right, the P of T for this sample space. Okay. The P of head in this sample space is also equal to 1 over 2. Okay, for one flip. This is what we're looking at. So here we are doing the probability of tails occurring for one flip is 1 over 2 times 1 over 2, which is equal to 1 over 4. This is how you will determine your P of x equals 0 instantly. You got it as 1 over 4 for this case, and obviously if we do it the long way, this is T, which is 1. There's one chance of getting double T over 4. which is our full sample space. This is the whole point of doing it using this method. It's by doing it in one direct way, knowing the probabilities of one simple flip, you will be able to determine it for x equal to 1,000, x equal to 2,000, doesn't matter. You will be able to calculate it much easily, and we'll see that in an example later on. But this is the basic concept. So let's look at if x is equal to 1. So remember, x is equal to 0 as in no head. X is equal to 1, meaning the probability is of getting one head. All right? This is going to be basically the probability of getting head and tails plus the probability of getting tail and head. Why? Because it is either we are going to get this first one, head and tails, or we are going to get tails and head. That is why we are adding them up, because this is simply the same as union. We are adding this plus this. So if we simplify this, this is P of H times P of T plus, remember, this plus is because this is like an or, okay? P of tails times P of head, okay? If we just substitute in the values now, we're going to see it's 1 over 2 times 1 over 2 plus 1 over 2 times 1 over 2, which is the probability of just one flip, one coin flip. So it's equal to 1 over 4 plus 1 over 4, which is equal to 2 over 8, simply 2 over 4, sorry, or simply 1 over 2. So it's a 50-50. It's a 1 over 2. If you notice, if we look at it, the old method we usually do it, we're going to look at these two cases, this case and this case. How many times is head coming twice? It's 2 times. So it's going to be 2 over 4. Okay? So if I want to make this clear, the purple early on was 1 over 4. And the orange, we have 2 of them. So it's going to be 2 over 4, which is equal to 1 over 2. Okay? This is exactly the same thing. Now we see when we are doing P of x equal 1. So 0 was the purple. P of x equal 1 is the orange. This is the definition of it. And now if we look at x equal 2, so the P of x is equal to 2. 2 was in green. Yes, 2 was in green. 2 heads. This is basically meaning that we are going to get 2 heads in a row. So this is P of 2 heads. Okay? In other words, this is basically when we get this one case, which is heads and heads. So it's P of heads and heads. And we know that this is equal to P of H times P of H. We know that P of H is half, so it's half times half, which is equal to 1 over 4. Again, when we look at it back here, we know that there is only 1, and it's all out of 4 sample spaces. This is the whole idea of how to do it. Usually, how this is displayed or how it's shown is in a table. A table like this with all your probabilities. The top part is going to be x, okay, x. And the bottom part is going to be your probability p. Okay, or in other words, this is p of x, large X. And then this is basically this is when we are writing p of x equals small x. This is the same thing. And this is just your large X when it's equal to small x. So what are the values we had? We had the value 0, which was in purple. We had this value 0. Then we had our value 1. Then we had our value of 2. So this is our table. The probability here is going to be equal to of 0. We calculated it to be 1 over 4. This is 1 over 2. And this is 1 over 4. This is the probabilities that we have already calculated. If you notice, when you add up all the bottom ones, if you're just adding these up, this plus this plus this, this has to always be equal to 1. This is your total probability. It has to always be equal to 1 because all your probability, all the chances that you have, has to eventually be equal to the entire thing. All right? So this is just the explanation from the background. Yani this, I'm just writing it all, showing you how the explanation is done. An example, if I would give you directly, so let's say we have a dice. Then directly, I'm telling you we have a dice. Okay? We know that the dice, the sample space of it can be 1, 2, 3, 4, 5, 6. صح ولا لا? We know the sample space. When you roll a dice, you can get any of these numbers. Now, let's say rolling a single dice, okay? When you roll a single dice, you can get any one of these values, and we know the probability of each one is 1 over 6, 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 and 1 over 6. We know this probability already, that the probability of getting any number of these is going to be 1 divided by 6. So if we want to draw, we can draw our table directly. Then we can draw our table directly. Oops, 1 second. And we have here x equal x, okay? And at the bottom, we have the probability of x equal x, small x, so large x equals small x, or sometimes this is also mentioned as small p of x, okay? This is just notation, don't worry too much about it. We know that for 1, 2, 3, 4, 5, and 6, this is our x values, 1, 2, 3, 4, and 5, 6. We're going to have a probability of 1 over 6, 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 and 1 over 6. And the total has to be equal to 1. Why am I writing this down this way? And what's the whole point of having it all in a table like this? This way, you can directly find the probability of any of these directly from this table. This is the whole idea. Yani, so let's say that x, like we want to know when we want to roll a die. So our big variable x is when we get the value 3. Okay. So basically this means that the small x is equal to 3. We're simply just going to go to the number of 3 and we're going to find the probability of it directly, which is 1 over 6. This is the whole concept. Obviously, you're not going to have to go through all of this in the exam. This is just the concept of how you can see this table and understand what it means. Okay. When we are finding this, we are finding our x variables, our random variables. It depends from 1 to 6 in this case, and we have the probability of each. I know I went through this very quickly, but I just wanted to start it off slightly. Inshallah, in the next session, again, I will go over this very clearly with the continuous variables as well. But I just wanted to start this so you guys have a general idea of what is meant by all of these numbers. When I say x equal x, this is large x equal to small x. The large x is a random variable and the small x is the known variable. And this basically, like here, when we say small x, we know that x, the small one, is equal to 3. And this is the probability of that event occurring. Later on, we're going to see something called the mean and something called the variance and the standard deviation, which I will go very clearly through, inshallah, in the next session. And they are dependent on understanding what this table basically is. So once you understand what this table is, you're going to be able to simply apply all of these using just basic equations, and we'll be able to move on. Due to time, I'm just going to stop right here with this. Inshallah, next session, the next